Hello? Hello?
Hello.
All right, calculus.
Hello?
Hello.
Hello?
Hello.
All right, this is calculus 1. Hello.
Hello.
Okay, 3.4 part 2. Hello. Anyway, all right, so this goes back to some special rules that go along with this. Now, inside a log rule or inside an ln rule, so if there's a multiplication happening inside the ln, what could I do with it? No. If it's a multiplication, it's a rule that goes with ln and log. It's a plus, thank you. I can separate it. It's a plus. And if there's a division, that is a
Minus.
thank you. It is going to be a subtraction. So I'm going to break this up to make it a whole lot easier. See this thing? This thing looks like a hot mess, doesn't it? Yes, because I could do the ln of that, right? So it'd be ln, but there's a chain rule. But inside the chain, there's a product quotient rule with a chain.
Yeah.
Chain, product, quotient, product. Yeah, something like that. All right, so you don't want to do all that, right? Okay, so we're going to use some special rules to go along with that. So let's break it up. So now, if this is a product and these are being multiplied, what am I going to put in between those two? Plus. So I'm going to break that up. So I'm going to say ln of 2x minus 1 cubed plus ln of 2x to the fourth plus 1 to the, what's my power? 1/2. Very good. 1/2 minus ln of x. Now, look at the restrictions on my domain. Why does x have to be greater than 1/2?
Because inside should be 0.
Yeah, but it's more than that though. More than that. Is there some place in where?
Is it going to be negative? Like, what is it called?
Yes.
Because there's going to be 0
Right here.
Yeah.
on the left.
Right here, because of this right here, when I plug it in, so my radical, I can't have negatives, right? Okay, and over here, I would get a negative. Am I allowed to have any negatives there? Say no. No, I'm not allowed to have any negatives here. So what do you get when you have ln of 0? Check your calculator. Just put ln 0. What do you get? Undefined. Very good. That's where my restriction is. It's going to be undefined. So I cannot have 0 in there. And right here, I would get 0. Because of this thing right here, I would get 0 there. Okay? So that's explaining the restrictions on my domain here. So I cannot have anything like that. So now, can I go through and actually clean this up a little bit? Let's take a look at this over here. Can I now clean that up? What happens to my exponents in an ln? The exponent. See this 3? Where's that 3 going to go?
Like 4.
It goes out front, right? I can go out front. So I could rewrite it as 3 ln of 2x minus 1 plus 1/2 ln of 2x to the fourth plus 1 minus ln x. That's going to make everything a whole lot easier, right? So this is still my y, right? I haven't actually done anything yet, except for try to simplify this to make my math a whole lot easier. Now we're just going to take the derivative of each part. So the derivative of this, so it's going to be a chain rule now. So the derivative of the inside is going to be, it's going to be 2, right?
Mm-hmm.
Times the 3 that's already out here. So it's going to be 6, right? Okay, times, what's the derivative of the ln? Okay, 1 over 2x minus 1. Very good. Plus, what's the derivative of the inside? 8x cubed, right? What's that 8 times the 1/2? So now it's going to be 4x cubed, right? Did I lose anyone there? No? Okay. So times, what's the derivative of the ln? 2x to the fourth plus 1 minus 1 over x. Okay, let's try to clean it up a little bit. So this is my y prime. So y prime is going to be 6 over 2x minus 1 plus 4x cubed over 2x to the fourth plus 1 minus 1 over x. If I wanted to combine all those, that would be a hot mess. I don't want to though. Okay? I would have a nasty looking denominator and my numerator would look even worse. But guess what? That's the derivative.
Oh, sorry, I have a question.
Yes.
How'd you get 1 over 2x? Like I see where you kind of get it, but I don't know how. Is it 'cause
1
ln
over 2x. Where? This one right here?
Yeah, like how'd you get it to this fraction? Like because
Okay, see this? This piece right here, right? So what's the derivative of ln x?
1 over x.
1 over x, right? Okay, so what's the derivative of ln of 2x?
1 over 2x.
Yeah, so it'd be 1 over 2x, but what's the derivative of the inside? 2. Right? Okay, because the derivative of the inside times the derivative of the outside. So we just keep this right here. So the derivative of ln x is 1 over that. Whatever that is. Okay, and in that case, my that is 2x minus 1. That's where I get that from.
Okay.
Does that make sense?
Yeah.
Okay, so that's the same reason why I did the same thing for each one of these. So the ln was 1 over that. The ln is 1 over that. Okay, and cleaned it up.
But you still got the derivative when you put it in front.
Yeah, take out the derivative, right? So the derivative of the inside would be 2. Yeah?
Yeah.
So the derivative was 2 times 3 gave me the 6. Okay? The derivative of the inside was 8x, right? So it's the, I'm going to come over here. So it's going to be 8x cubed times, what was out front?
1/2.
1/2. And that's what gave me my 8 over 2, which was the 4 right here. Does that make sense? Hello? Are we okay with that? Alright, and the 1 over x?
Because of the n over.
Yeah. Alright, now, does that make a whole lot more sense now?
Yeah.
Okay, good. Alright, so, there we go. Okay. Okay, so, let's take a look at the next one. Logarithm and the properties useful of finding derivatives of functions that involve product, quotient, powers. Logarithmic differentiation. Use the following facts. Logarithm of a product is a sum. So if it's a multiplication, you add. So logarithm of a quotient is difference. You subtract. Logarithm of a power is a product. Okay, if it's going to be squared, it's going to be times itself, right? Yeah. Okay. Okay. So now, I'm going to give you guys 3 minutes. I want you to actually no, not on this one yet. Okay. I think I have one that I was supposed to do. I thought it was this one, but it's not. All right. So see this? This is nasty, isn't it? Yeah. There's a. My F has a product in it, doesn't it? And the G has a chain in it, doesn't it? So, let's not do that. Okay, so to clean this up, we could use ln rules. I could ln both sides. So if I ln both sides, it's going to be ln of y equals ln of x squared radical 5x plus 1 over 3x minus 2 to the third. So I can ln both those.
Wait, but how?
Huh?
How?
Okay, so whatever you do to one side, you do to the other.
Yeah, but like.
So if I am squaring both sides. If I were to square one side, I would square the other, right?
Yeah.
Same thing goes for this. I can ln both sides. And this is going to make a lot of the math easier if you use some of these rules. So I can ln both sides. So now when you have an ln like this, to undo an ln, I would e both sides. So if I were e, because e to the ln would be just 1. Are you going to dental school? Yes, you.
No.
Oh, because you're going to Colgate University wants to talk to you. Colgate.
Wow. Wait, okay, so what's LN?
ln is the natural log. So
Base 10?
yeah, so if log is base 10, so log OG is base 10,
Yeah.
right? So ln is actually log base e. So it's the same thing. So if I were to take a log and do 10, that would actually undo that there. Okay, so the base is going to be different. All right, so we can ln to actually clean up some of this stuff. All right, now that I have that, okay, so over here, I'm going to do this implicitly now. So what is the derivative of the left side?
1 over y dy dx.
Very good. So it's 1 over y dy dx, right? Yeah?
Yeah.
Okay. And that's going to be equal to,
And then x squared.
so it's going to be ln of x squared plus,
1 half ln.
no, ln
Plus
Root
5x plus 1 to the 1 half, don't skip that step, and then minus ln of 3x minus 2 to the 3rd power. All right, are we okay on this? Or did I lose anyone yet? Hopefully I did not lose anyone yet.
Yep.
Now, what's the next step I do?
Find it. Like put the
Powers,
powers.
right? Clean it up to the powers. Powers and an ln could go out front. So it's going to be, okay, I still have 1 over y dy dx equals, I still haven't done the derivative of the right hand side, I just took care of that already. So that's going to give me 2 ln x plus 1 half ln of 5x plus 1 minus 3 ln of 3x minus 2. And now I do the derivative. Keep bringing this down. I'm probably not doing this correctly because my lines are not correct. All right, so now I do the derivative of this.
2 over
2 over
x.
x.
And 1 over.
No. What's the derivative of the inside?
5.
5, right?
5 over
5 over 2, right? So it'd be plus 5 over 2 times
2.
1 over 5x plus 1. All right, are we okay on that step right there? Did I lose anyone? Anyone have any questions before I keep going? I don't want anyone lost on this because this is going to get weird. Yeah? Good? Okay. Now, next one. So it's going to be minus, so the derivative inside is 3, right? So it's going to be 3 times 3 is 9 over 3x minus 2, right? Because the derivative of the inside was 3, and the outside is 3, so that's what we get. Yes? Okay, so I'm going to carry this over to another slide because the next thing is going to get interesting. Okay. Here, I'm going to rewrite this step right here, okay? So I get 1 over y dy dx equals, what was it?
2 over x plus 5 over 2 times 1 over 5x
5x plus
plus 2.
2?
Minus
Minus,
9.
plus 1.
Plus 1.
Plus 1, sorry.
Minus 9 over 3x
9 over what?
3x minus 2.
Like that?
Yes.
Okay, so I'm trying to get y equals, right? And I'm trying to get y prime. Isn't y prime the same as saying dy dx?
Yeah.
So I'm trying to get the dy dx by itself. So to do that, I need to do what here? Multiply both sides by
Y.
y,
Y.
right? But why?
Y.
So the y's over here is going to cancel. So I'm left with dy dx equals, okay, I'm going to put the y out front now. Y quantity 2 over x plus, let's say this is going to be, I'm going to just clean this up, 5 over 2 quantity 5x plus 1 minus 9 over 3x minus 2. Now, I have the derivative, don't I? Say yes.
Yes.
Now, when we did implicit the other day, I needed to have, on one of the questions, I needed to have everything on the right-hand side just x's, right? Do we know what y is equal to? Say yes.
Yes.
At the very beginning of my problem, y is this.
Wow.
So y is this. So I'm going to carry that over. So I need you guys to help me on that one. Because I know that y is equal to,
X squared multiplied by square root of 5x plus 1 divided by 3x minus 2 to the third.
like that.
Yeah.
So that is the value of y. Because I'm trying to get all x's on the right-hand side, I know what y is. So can I substitute that? Can I put it back in?
Yes.
Say yes.
Yeah.
Yes. Yes. It's going to be ugly, but guess what? Some of these do come out to be ugly. Be glad you don't have to factor it. Okay? Right now, we're just trying to get to the ugly right now. Okay? It all works out. Now, I'm going to replace y right here on the right hand side with all of that. So I'm going to say that dy dx, so that's my derivative, is equal to x squared quantity, so that's going to be radical 5x plus 1, right, over 3x minus 2 to the third times quantity of 2 over x plus 5 over 2 5x plus 1 minus, actually let me clear this out, minus 9 over 3x minus 2. Yes, it's ugly, but sometimes they are. Hmm? Yeah, that's the answer. Are we okay here now? Anyone got questions? Or are you guys still just writing it down? Writing it down.
Ah.
Yes.
G
over y. Oh yeah. So because at the beginning right here, when I took the derivative of this right here,
Oh, okay.
yeah, that's where I get my 1 over y, right? But since it's implicit, I took the derivative of y, right? I took the derivative of y, so therefore I had to write dy dx when I did that. Does that make sense?
But okay, so like the weird thing is like, how do you know what you're doing? Like, cause you were like, oh, we're just gonna do the ln, and then how did you know? Like.
Okay, because this one's in the notes for this section right here.
Mm-hmm.
Now, remember what at the beginning I said, do you know what? We could do this without this method. We could, okay? I'm gonna make another slide now. I'm gonna show you, okay?
Okay.
So I'm gonna make another slide. So you're gonna read this to me, okay?
Can I take a picture of that one real quick?
Give me a second. All right, so it's gonna be y equals, what was it?
X squared, square root of 5x plus 1 over 3x minus 3 cubed.
Okay. So if I go through and I say, hey, all right, I can do this. I can. So all my top would be considered the what? F, right? All the bottom would be my G, right? But when I do my F prime, the derivative of the top is a product rule by itself, isn't it? So if I'm going to take the derivative of the top, I can do it. So, but it's going to be a product rule, and it's going to look ugly. But we can. So let's do it then. So the derivative of the top, so it would be, remember, so it's the first time, right? So it's f prime g, right? So in this case, it's going to be, so 2x times 5x plus 1 to the 1/2 plus sign. Then it's going to be x squared times the derivative of this piece right here. So it's going to be 1/2 5x plus 1 times the derivative, so hold on, negative 1/2 times the derivative of the inside, which would be 5, right? Yeah? Okay, so I can clean this up a little bit. Just a little bit, just because of this piece. So f prime would be, let's see, that's going to be 2x, 5x plus 1, 1/2 plus 5 over 2x squared times 1 over 5x plus 1 to the positive 1/2 there. Okay, so that's my f, right? So that's the derivative of the top. Yes? Okay. So let's do derivative of the bottom. So g prime would be 3x minus 2 squared times, okay, so there's that, and times the derivative of the inside. Derivative of the inside would be 3. So that would clean up to 9 quantity 3x minus 2 squared. So I would be plugging all this in. So if I do it as a quotient rule, my quotient rule is f prime g minus g prime f over g squared. That's the quotient rule. So I would be plugging in all of this for my f prime times my g minus my g prime, which is here, times f, which is all that again, all that up here, over g squared. So the value is going to be exactly the same. I'm just teaching you another way to do it to make it simpler.
Which is the ln.
Yeah, which is the ln, which actually broke it up into equal parts using implicit differentiation. Okay? So yeah, that's where it goes and that's where it's coming from. So this is what you want a picture of?
Yeah.
Okay. All right, so, okay, step logarithm differentiation. Same thing we hit right there. All right, how about this? What I'm gonna do for you guys, so I'm gonna stop right here. So I'm gonna slow down for this last section. I'm gonna give you guys 15 minutes for, almost 15 minutes for homework, working together. So please work on this right now. So yes, like I said, I'm gonna slow down on this. So hopefully you guys are gonna have time. There's not gonna be a part C to the homework, but you guys will have time in class to actually get it done. All right? So don't forget, like and subscribe.